Hi, in this lesson we want to go through the laws of logarithms. Now, a logarithm is a function that represents the exponent to which a specific base must be raised to obtain a given number. It answers the question, to what power must the base be raised to produce the given number. So this is the format of a logarithm if you're not familiar. Y is equal to log bx, where y is the one that is answering the question, to what power must the base be raised to produce the given number. So to what power must this base be raised to produce this number? And logarithms are directly linked to exponential functions, which have the form y is equals to b to the power of x. So whenever we don't know what x should be in order to achieve this number, such as the example 8 is equal to b to the power of what, or 2 to the power of what rather, we want to answer the question, what should we raise x to in order to achieve this number 8? So that's where logarithms come in, and basically by inputting this, to what number should I raise 2, which is our base, in order to get 8, and then the answer you get will be 3. So what are the laws surrounding this new domain of values? What are these laws that we must consider when working with logarithms, algebraically at least? So first off, we have the product rule, which states that if we have the log of the same base of x, y, where x and y are two numbers being multiplied together, this will result in log bx plus log by. So each is assigned its own logarithm. Then we have the quotient rule that states log b of x over y is equal to, as you would guess it, log bx minus log by. Then lastly we have the power rule, which states log of base x to the power of n. This will be equal to n multiplied by the log of base to the power, log of base x basically. So the n comes in and multiplies the entire term. So again, these laws of logarithms are used to simplify and to solve equations, or to simplify expressions basically. And it's important to recognize that logarithms are defined only for positive real numbers, where the argument x, the number or the value inside these brackets, is called the argument, and usually represented by x. We say that the argument of a logarithm must be greater than 0. For base b logarithms, the base b must be greater than 0 and not equal to 1. So we cannot have the base being equal to 1, because as you might think it, how would we then be able to answer this question? If 8 and we have the base as 1, to the power of what can we raise 1 to the power of in order to get 8? There is no number that exists that we can raise 1 to that will give us 8. So we just end it here and say that b cannot be equal to 1. X has to be greater than 0, like that.